All right, this is AM U1 L10. This is lesson 10 in Unit 1, and it's our last lesson in this fundamentals unit. And we're going to talk about inequalities. Now, when you graph inequalities on a number line, you use either an open circle or a closed circle. An open circle means the number is not exactly included in the set, but it's almost. So this is when you've used the symbols greater than or less than. A closed circle means that number is included. It's your less than equals to, or your greater than equal to, or your equal sign. All right, for example, if I have x is greater than 2, I'm going to use an open circle because 2 is not included in that set, but it's right up to 2. Now, we're also going to use something called interval notation. And for interval notation, you use the symbols with parentheses or brackets. Parentheses are going to be used for a number that is next to a greater than or a less than sign. So it's like your open circle. Whereas your brackets are going to tell us like a closed circle. So we'll use brackets for numbers that are less than or equal to or greater than or equal to, with one exception. When you have your infinite symbols, those are always bound by parentheses because we don't really know where those go to. All right, let's talk about set notation. If you're going to use set notation, this is what it would look like. You have the brackets on either end, just like a set, and you would read this x such that x is less than or equal to 4, okay? On a number line, what would that look like? Well, it would have a closed dot here and go this direction. So interval notation should mirror what that looks like on a number line. What do you have at the far left of this? Negative infinity. What do you have at the far right? The 4. And as I told you, the infinity is always bound by a parenthesis, whereas since we had the equals to, this would get a bracket. So this is what that would look like in interval notation. So let's grab some of those first examples and have a look at what they're going to look like. Okay, here's number 1 on your guided notes. So I need to write this first of all in set notation. So that's going to start with the bracket, x such that x. They all start like that. Okay, now my graph starts here at the 3, and it has a closed dot. So that lets me know I'm going to need the equals to sign part of that. Now, do I want greater than or less than? Well, where's my set going? It's going towards the numbers that are greater than 3. So I'm going to use the greater than symbol, 3, and then you just close your bracket. Okay? X such that x is greater than or equal to 3. Now for interval notation, this should mirror your number line. Where does your number line start? Where does your set start on the number line? It starts with a closed dot at 3. So you're going to start with a bracket and the 3. Now what's over here on the right hand side? Positive infinity, and we always use a parenthesis with that. Okay? All right, let's look at this one. My set notation, I'm going to start with a bracket and x such that x. Okay? Now I have an open dot this time, and my set is going to the left towards the numbers that are less than. So it's just going to be the less than symbol. If you notice, this symbol points the direction that the arrow is going. So that might help you there. Okay, what number am I at? -6. So that's all there is for set notation. Now let's go to interval. All right, what is on the furthest left of my number line for this set? Well, it goes all the way to negative infinity, doesn't it? So this one is going to start with negative infinity, and because of that, it's going to start with a parenthesis. Now, what is the furthest thing on the right of my graph? Well, it's that -6, and the -6 has an open dot, so I'm going to need a parenthesis. All right. Now, number 3 has the entire number line covered. So that is in set notation, you can write that with the fancy R for real numbers, or you can put the set of real numbers, however you want to put that. Now for interval notation, it's going to be from negative infinity to positive infinity. Okay, let's move to the next ones. Okay, this is the second section in your guided notes, and this is called compound inequalities. Now, how do you know the difference? Well, look up there at 1 through 3, and then look at 4 through 7. I want you to look at the number of endpoints. How many endpoints did those graphs in 1 through 3 have? 1 or less, huh? Like in number 3? So 4 through 7, how many endpoints do you see on these problems? They all have 2. So that's how you know that these are compound. Now there's 2 different kinds of compound. There's your AND problems and your OR problems, which are your unions and your intersections, okay? OR is your union and AND is your intersection. So how do you tell the difference? Well, if there's a gap in between, you have 2 graphs and there's a gap in between, that's an OR problem, OR. If, like number 6 and 7, you have 2 endpoints and your graph is in the middle, well, that's an intersection problem. That's an AND problem. So let's just look at how we're going to write this. First of all, in set notation. All right, you're going to have 2 different expressions here within one set because you have 2 different lines. And you are going to have the word OR. All right. Where does this start? It starts at 1, so we're going to do x such that x, well, what about x? It's less than 1, isn't it? Because it's going the other direction. Or x is greater than 5. So you're just describing both sections in one set. All right? Now, interval notation is going to be the same way. You're going to have 2 intervals because you have 2 graphs. So let's start with the first one. What is on the farthest left of your graph, if you could go down there? The negative infinity, right? And when you have negative infinity, you have the parenthesis. All right, what's on the right-hand side of this graph? Positive 1. And it's an open circle. Then we're going to use the word OR, okay? Or, you know, more technically correct is if we just use the union symbol. So let's go with that. Now, here, where does this one start? Well, it starts with an open circle, so that's a parenthesis, at 5, and it's going to end with the positive infinity. So there you go, okay? So take a look at that. This is this graph in set notation and interval notation. Okay, now let's look at number 5. So we're going to start with set notation. Here, x such that x. All right, let's look at our first graph down here. It goes from -7 all the way to the left, so, and it's an open circle. So this is x less than -7. Or, all right, what is this graph showing? Well, it is showing x greater than or equal to, because it's a solid dot, positive 2. All right, now let's write this in interval notation. Let's look at this one first. Where does it start? It starts all the way down there at negative infinity, and then it goes to -7, and since that's an open circle, I'm going to use a parenthesis. Okay, we're going to have the union symbol. Then where does this one start? Well, it starts at positive 2, and since that's a solid dot, you're going to use the bracket. Where is it going? It's going all the way to positive infinity, so you would have your parenthesis there. All right. Let's look at number 6. Now, this one is a union. It's an AND, so it's a little bit different, but it's still going to start off with x such that. Now, we're not going to have an x at the end because we have numbers at both ends of our graph. So we're going to start off with the number that is at the far left, which is -4. And then all of the numbers in this line, what are they? Well, they're greater than 4, so that means 4 is less than x. All of these numbers here, these are your x's. So you're trying to describe the x's. All right, so x is in between -4 and 0, okay? So this is red, x such that -4 is less than x is less than 0. X is between -4 and 0. Now, writing your interval is actually much easier because you only have one interval. All right, look at the left-hand side. It has an open circle, so that's a parenthesis. What number is there? -4. All right, what number's on your right? 0, and it's also an open circle, so you're going to have a parenthesis there. Then let's look at this last one. We have a closed dot here at -1 and an open dot at the 8. So let's get ready for our set notation, x such that. Now since I have, something on either end, that lets me know my x is going to be in the middle here on my set notation. So what's all the way down here? -1, and those are going to be less than or equal to x because it's a solid dot. What's over here on the other end is the 8, and the x's are less than 8. See, all of these numbers here are between -1 and 8. And that closes the set. Now, to write this in interval notation, you have a solid dot on the left, so that means a bracket on the left. What number is here is -1. All right, what number is here? 8. And since the 8 is an open dot, you're going to have a parenthesis, okay? All right, so that's, like your terminology. Now let's just solve some inequalities, and we are going to graph them. We're going to write them in set notation and in interval notation. The thing you want to always remember when you're solving inequalities is they're just like solving linear equations or regular equations, except for one thing. If you multiply or divide by a negative number, you have to flip your sign. Okay, so be sure and remember that. So let's just get started. We're going to start over here on the left, and we're going to simplify by first getting rid of the parentheses. So we're just going to distribute. -3 times 4x is -12x. -3 times -2 is +6. Minus 4x is less than -90. All right. Next, let's go ahead and combine -12 and -4 gives you -16x plus 6 is -90. And then subtract 6 from each side. So -16x is less than -96. So we're going to divide by -16. And be careful. Now we're dividing by negative, so what that's going to do is x, flip my sign. Negative over negative is positive. 96 divided by 16 is 6. So we want to graph this on a number line. So, and you don't have to get too specific. 1, 2, 3, 4, 5, 6. Since this is greater than, it's going to be an open circle and the arrow going off to the right. Now for set notation, we're going to have x such that x is greater than 6. And then our interval notation, we'll look at what it does on the number line. It starts with an open circle, so that's a parenthesis. It starts at number 6, and what's over on the right hand end is the positive infinity, so we need a parenthesis, okay? Okay, here's number 9. So when we get ready to solve, first let's look over here on the left-hand side. Let's get rid of the parentheses. We're going to distribute that -5 in. So -5 times -2 is +10x plus 35 is less than or equal to 7x plus 23. Okay, so our next step is to get rid of one of your variable terms. They're both positive, so I'm going to subtract the smaller one from each side. So now I have 3x plus 35 is less than or equal to 23. Now I need to get rid of the number joined to the variable term by addition subtraction. So I'm going to subtract 35 from each side. So now I have 3x is less than or equal to -12. Divide both sides by 3. and x is less than or equal to -4. Okay, let's graph it. So go to your number line at -4. This is a less than or equal to sign, so we need a solid dot. And the numbers that are less than -4, well, they go off here to the left. All right, set notation. We're going to have x such that x, all right, here you go right here, less than or equal to -4. And then the final thing, our interval notation. Well, look at your number line. What is on the furthest to the left? It goes all the way to -infinity. And when you have infinity, you have a parenthesis. Now, what number is on the furthest right of the graph? -4. And that's a solid dot, so you're going to need a bracket. Okay, here's problem number 10 on your guided notes. So let's just start simplifying both sides. First of all, I look over here. I can combine -5x, -3x, and get -8x minus 2 greater than or equal to. Now when I distribute this, I'm going to get -8x minus 2. And I'm sure right now you already see you have the same thing on either side. Let's go ahead and do one more step though. If I need to get rid of one of my variable terms, I'll get rid of this one by adding 8x to each side. And what's that going to do? It's going to leave me with -2 is greater than or equal to -2. Well, -2 is greater than or equal to -2. This is a true statement. Sometimes you get a false statement. Like if I had -2 is greater than or equal to 0, well, that's not true, so that would be the opposite effect. But anyway, if it's a true statement, what you have there is everything works. So it's the set of real numbers. All right. So in set notation, you would just put the fancy R for real numbers. In interval notation, well, let's graph it. On your number line, what's that going to do? It's going to cover the whole number line, and it's going to have the arrows go in either direction. So when you try to write that in interval notation, what's over here on the left? -infinity, so you need a parenthesis. What's at the end on the right? +infinity, so you need a parenthesis. So here is set notation, here's your graph, and there's interval notation. Okay, let's look at number 11, and just like the others, we're going to first simplify each side of the expression here, or the inequality. So we're going to distribute 8 into the set of parentheses, and that's going to give you 40 minus 16x is greater than. And then when I distribute -10 into here, I get -10x plus 40 minus 6x. Okay, let's continue to simplify over there. Nothing here is going to change. -10x minus 6x is going to give you -16x plus 40. All right, the next thing we like to do is get rid of all but one variable term. So I've got -16 here. Let's get rid of it by adding it. And to keep the inequality balanced, we have to do it to both sides. Now what I have is 40 is greater than 40. Well, this is not a true statement. Like in the last one, this is a false statement. So when your statement is false, that means you have the empty set. There is nothing that will go into this inequality and make it true. So it's just the empty set. You have no set notation because there's no set. You have no graph because there's no numbers that work. And you have no interval notation because there's no interval to notate. So let's move on. Okay, now we're going to look at some absolute value inequalities. And first we need to recall the steps that we used when we were just solving absolute value equations, and that was to isolate the absolute value and then consider both cases, the positive and the negative, because absolute value could have been positive or negative, you don't know. All right, this, it's already isolated, so we're going to the two cases. Now in absolute value, when you consider two cases, your first one is the positive case. So we're just going to drop the absolute value sign and leave it just like it is. Now, on the negative side, we're going to have 5 minus 10a. You're going to flip your sign and make the number negative. Okay, now let's just solve both of them. I'm going to subtract 5 from each side. So I have negative 10a is greater than 10. Divide both sides by negative 10. A, now since I divided by a negative number, I've got to reverse my sign, negative 1. Okay, over here, I'm going to subtract 5 from each side. Negative 10a is less than negative 20. Divide by that negative 10, so that means I'm going to flip my sign. Okay, let's just go ahead and graph it first. It's always easier for me if I do that. All right, a is less than negative 1, so I'm going to have an open dot at negative 1, and my arrow is going to go off to the left. For a is greater than, and this is going to be a positive 2, sorry. For a is positive 2, that's going to be an open circle and off to the right. Okay, first set notation, x such that. We're going to have 2 of them now because we have an or, we have 2 different graphs. So either a, and this should be a, sorry, a such that a is less than negative 1, or a is greater than 2. So there's your set notation. Now for interval notation, what's over here at the far left of this graph? Negative infinity. So that goes here. What's at the end? Negative 1. And it's an open dot, so it's a parenthesis. Now instead of the or, when you're doing your interval notation, you're going to use that union symbol. And then here, what's at the far left of your graph? Positive 2. It's going to be a parenthesis because that's an open circle. And then positive infinity down there on the other end. And there you go. Okay, let's look at number 13. Once again, the absolute value is already isolated, so I can go to considering both cases. My positive case is just like it's written without the absolute values. My negative case is where you drop the absolute value, you flip your sign and make the other side negative. Okay, so just solving, add 2 to each side. I have negative 8x is greater than or equal to 32. I'm going to divide by negative 8. So that is going to make me flip that sign. And 32 divided by negative 8 is negative 4. Okay, we come over here and I'm going to add 2 to each side. So now I have negative 8x is less than or equal to negative 28. I'm going to divide both sides by negative 8. So that's going to have me flip that sign. All right, negative over negative is positive. 28 over 8 will reduce by 4. So that'll give me 7 halves, positive 7 halves. All right, let's graph it first. That always makes it easier for me to see. So 1, 2, 3, negative 4. I'm going to need a solid dot since I have the equal sign there. And if x is less than or equal to negative 4, where are those numbers? The numbers that are less than 4 are off this way. All right, now I'm going to go to 7 halves, which is in between the 3 and 4. It's a solid dot because of that equal sign. Now, where are the numbers that are greater than this going? They're going off here to the right. All right, so set notation is going to be x such that x, all right, first of all, it's less than or equal to negative 4, or x is greater than or equal to 7 halves. Then my interval notation, it starts down here. My first set starts down here with negative infinity. So I've got parenthesis, negative infinity, comma. What's at the end of this line? Negative 4. Okay? And we're going to use the union symbol. Now, how do I describe this one? Well, it starts at, 7 halves. And this is going to be, hang on, these are going to be brackets. Why? Because these are solid dots. Okay, so put brackets and then positive infinity. Now your infinities always have parentheses. So there you go. Okay, for number 14, this time our absolute value is not isolated, so we need to do that first. So add 4 to each side, and that's going to give you absolute value of x minus 3 is less than or equal to 4. Now we're ready to consider both cases. So either x minus 3 is less than or equal to 4, that's our positive case, or x minus 3 is greater than or equal to negative 4. And let's just solve. Add 3 to each side. So here I have x is less than or equal to 7. When I add 3 to each side over here, I get x is greater than or equal to negative 1. Now I'm going to graph this first because having a picture of it kind of helps me. So first, x is less than or equal to 7. I'm going to go to the 7, solid dot, because I have the equal sign. All right, where are the numbers that are less than 7? Well, they're over to the left here. So it goes this way. Now this one is going to go to negative 1, and it's going to be a solid dot because I have the equals to part. Where are the numbers that are greater than negative 1? They go this direction. So you can see you're looking at this section right here. You don't have two separate sections. You have an overlapping or an intersection. All right, so for our set notation, x such that. Now, since you have this graph here, your x's are the numbers in between here. So when you write your set notation, these numbers are going to be at the end, and x is going to be in the middle. So now you got to figure out what signs go here. Well, negative 1 is less than or equal to x, and x is less than or equal to 7. So there's your set notation. And then as far as interval notation goes, what's on the end here is negative 1, and it is a solid dot. What's on the other end is 7, and that's also a solid dot. So there you go. Okay, let's look at number 15. Now the first thing you notice is that your absolute value is not isolated. So we've got to get rid of the 8. The 8 is joined by multiplication, so we're going to divide both sides by 8. All right, that's going to leave you with absolute value of 3 minus 3x is greater than 120 divided by 8 is 15. Now we can consider each case. So the positive case is going to be 3 minus 3x is greater than 15. And your negative case is going to be 3 minus 3x is less than negative 15. Okay, we're just solving. Subtract 3 from each side. Negative 3x is greater than 12. Divide by negative 3. And that's going to flip our sign because we divided by a negative number, negative 4. All right, over here, subtract 3 from each side. So we've got negative 3x is less than negative 18. Divide by negative 3. And x is greater than, flip that sign, positive 6. All right, let's get a graph because it's usually easier for me to come up with the rest. All right, negative 4, x is less than negative 4, so that's an open circle. Where are the numbers that are less than 4? They're over here to the left. All right, 6, open circle. Where are the numbers that are greater than 6? They're off that way. All right, so our set notation, we've got x such that. Okay, we've got two different graphs, so we're going to have two different parts here. The first one, x is less than negative 4, or x is greater than 6. And then our interval notation, well, we're going to have two different sets with a union. So what is the furthest left-hand point over here? Well, it's negative infinity. So we'll have that. Now, what's the right-hand point of this graph? At negative 4, and it's an open circle, so we need a parenthesis. All right, let's do our union. Here, I've got an open circle, so I need a parenthesis. That open circle is at positive 6. Where does this graph end? At positive infinity, and we need the parenthesis there. Okay. Okay, number 16. Now, our absolute value is not isolated again. This time it's divided by 4. Well, how do you get rid of something that's been divided by? You multiply. So to isolate it, we're going to multiply both sides by 4. These cancel out. So now you have absolute value of 12 minus 4x is less than or equal to 8. Now let's consider both cases, the positive and the negative. The positive over here, nothing's going to change. I just dropped the absolute value signs. But my negative case over here, I'm going to flip the sign to greater than or equal to and make the other side negative, the opposite of whatever it is. So now we're ready to solve. I'm going to subtract 12 from each side. So I have negative 4x is equal to, is less than or equal to negative 4. Divide both sides by negative 4. And I'm going to get x. Now since you divided, you got to flip that sign. Greater than or equal to positive 1. All right, let's come over here. I'm going to subtract 12 from each side. So I have negative 4x greater than or equal to negative 20. I'm going to divide both sides by negative 4. So now I have x. Flip that sign, positive 5. Okay, let me graph this. It's easier for me to look at. So first of all, how do you graph x is greater than or equal to 1? Well, you are going to need a solid dot at the 1. Where are the numbers that are greater than 1? They're off to the right. Now, next I want to graph x is less than or equal to 5. Well, if this is 1, 2, 3, 4, 5, solid dot also, where are the numbers that are less than 5? Well, they're this direction. So you can see we have this segment with the 2 endpoints. We have the intersection. All right, so our set notation, x such that. Now remember, if your graph, if all of your x's are in between the 2 endpoints, then when you write it in set notation, your x is going to be in the middle. So what's down here? The 1, let me make the x such that 1 is less than or equal to x, and x is less than or equal to 5. And now to put it in interval notation, what's the end of your interval here? Well, it's a solid dot, so you're going to have a bracket, 1. What's at the other end? 5, and I should have written that on there. All right, and then a bracket there as well because it's a solid dot. One more problem. Okay, so the first thing we have to do is isolate the absolute value part. So what all's attached to it? 9 and 5. All right, 9 is attached by multiplication and 5 is attached by subtraction. So you create less of a mess if you get rid of anything joined by addition and subtraction first. All right, let's add 5 to each side. So now I have 9 times the absolute value of 2 plus 6x is less than 67 plus 5 is 72. So now I need to get rid of the 9. It's joined by multiplication, so I'm going to divide both sides by 9. Now the 9's cancel out, so I have 2 plus 6x, absolute value, is less than 72 divided by 9 is 8. Now I can break it up into my 2 cases. I can have 2 plus 6x is less than 8, or 2 plus 6x is greater than negative 8. And let's just solve. I'm going to subtract 2 from each side. 6x is less than 6. Divide by 6. Now there's no flipping this time because 6 is positive. All right, over here I'm going to subtract 2. So I get 6x is greater than negative 10. Divide both sides by 6. Once again, no flipping because I'm not dividing by a negative number. All right, and this is going to be negative 5/3. And I'm going to write that as 1 2/3 because it's easier to graph. So my next step is to graph this. Now, x is less than 1, and these are going to be open dots. So there's your 1. Where are the numbers that are less than 1? They go in this direction. All right, next I have x is greater than negative 5/3. Well, where is 5/3? It's just going to be in between negative 1 and negative 2. So you don't have to be that exact. So we're going to put an open dot somewhere in there. Well, if x is greater than this, where does that go? That goes that direction. So here's our overlap right here. And this is at negative 5/3. All right, so to write this in set notation, x such that. Now remember, since you have a segment with 2 endpoints, this time your x is going to be in the center. Well, what's at your left endpoint? The negative 5/3, and that is less than x, which is less than 1. So there's your set notation. All right, what about interval notation? Well, we have open dots on the left side, so that's going to be a parenthesis. What point is that? Negative 5/3. Where's the other end? At positive 1, and it's also an open circle. So there. That concludes Lesson 10. That concludes Unit 1. You are finished with the fundamentals in the class, and we're going to be ready to move on to the hard stuff now. Good job, y'all. See you later.